Hello students, how are you all? I hope you are all safe. Today we are going to discuss the chemical properties of acids from grade 10 science. So in chemistry, every time we used to discuss about the properties. First we used to discuss physical properties, next chemical properties. So in this lesson, we are going to discuss the chemical properties of acids. What is meant by chemical property? When one substance is added to some other chemical substance, what will happen? For example, an acid is taken and added in a piece of metal. What is the result of it? So this is what a chemical property. So let us discuss the properties of acids step by step. In this, mainly we will be discussing about 4 chemical properties. Let us see one by one. The first one is reaction with metals. What will happen when a piece of metal is added into acid? So a metal, when it is added to acid, it will give salt and hydrogen. Let us take an example. Zinc metal, which is added to hydrochloric acid HCl, and it will form. See, we know that zinc is more reactive than hydrogen. So when zinc comes here, it will displace the hydrogen. So we are getting zinc chloride, ZnCl2. Regarding writing the chemical formula, you might have studied in grade 9. If you have any doubts, you can comment. I will give some other video. And it gives hydrogen gas. Always we have to write a balanced chemical equation. So in that case, now we are going to balance it. In lesson number 1, you might have studied about the balancing chemical equation. You see, chlorine, we have to take higher atomic number. Chlorine, which is not balanced, there are 1 chlorine in the left hand side and 2 chlorines on the right hand side. So to balance this, we are going to write 2 in front of hydrochloric acid. So this 2 is common for this hydrogen also. See, now 2 hydrogen balanced. We know zinc is a solid and hydrochloric acid, it is aqueous, and it is aqueous. Hydrogen, obviously it is a gas. So this is the first chemical property. If you know this general equation, you can answer very easily. When a piece of metal is added into acid, it gives salt and hydrogen gas. Good, I hope you understood this. Let us go to the second one. Reaction with metal carbonates. Sodium carbonate, potassium carbonate, calcium carbonate, copper carbonate, like when an acid reacts with these carbonates, what will happen? Come, let us see. In the previous one, first I wrote the general equation, then I gave the example. Now we are going to see the example, then we will write the general equation. Okay. So let us take a metal carbonate. What shall we take? Shall we take sodium carbonate? Good. Ne2CO3, sodium carbonate. Let us take the same example, acid, hydrochloric acid, and it forms. Okay. What will form? When we put acid into carbonate, it will bubble. What kind of bubble will come? When we see the bubbles, it is a gas. We have carbonate. From carbonate, what gas will come? Very good. Carbon dioxide gas will come. And there is a metal and there is a non-metal. So when a metal and non-metal combines, automatically there will be salt. Good. So a salt will form. What salt will form? We have sodium and there is chloride. So it is sodium chloride salt. And what gas is released? Carbon dioxide gas is released. Also water is formed in this reaction. Very good. See, let us check whether the reaction is balanced or not. You see, there are two sodium and there is only one sodium on the right hand side. So to balance it, we have to put 2 in front of this. And this 2 is common for both Na and Cl. So now there are 2 chlorine atoms, but on the left hand side we have only 1 chlorine atom. So when we add one more 2 here, now you see this 2 is common for hydrogen and chlorine. So 2 hydrogen balanced, 2 chlorine balanced, 2 sodium balanced. And check oxygen, there are 3 oxygen atoms. On the right hand side we have 2 oxygen, here 1 oxygen. So when we add all together it is 3 oxygen. So I hope you understand this. Oh, I forgot to write one thing. What is that? State symbols. Very good. Okay. Metal carbonate. What is the state? It is a solid. Hydrochloric acid. It is aqueous. And salt is formed. Water is present, so this is soluble in water, so it is aqueous. Carbon dioxide is a gas. H2O, it is a liquid. Okay. From this, now we are going to write the general equation. What is the general equation? See what we have taken? We have taken metal carbonate and we added an acid. What are the products formed? First product, salt. Next, carbon dioxide and water. So what will happen if I take a metal hydrogen carbonate? Same products only. We are going to see only the carbonate. See, let me take an example. Sodium bicarbonate or sodium hydrogen carbonate, NaHCO3. So same thing will happen. It's a solid. When you take hydrochloric acid, aqueous, you will get the salt. What salt? Sodium chloride and carbon dioxide and H2O. Everything repeats. Okay. So we have discussed 2 major properties of acids. First one is reaction with metal. Second one is reaction with metal carbonate. And here there are 2 hidden questions. Notice this 2 gases, hydrogen and carbon dioxide. These are colorless and odorless gas. No color, no smell. So in this case, how will you confirm that the gas produced is hydrogen and in this case it is carbon dioxide? Do you know the answer? Wait, we will discuss after discussing the 2 more properties. The third one is reaction with the base. In the place of metal, we are going to add base. What is base? Opposite of acid. What will happen when acid is added to base? Acid is positive, base is negative. So what will happen? It will neutralize each other, nullify the acidic character. Base will nullify the acidic character. So what base shall we take? Okay, easily we can remember the base sodium hydroxide. Sodium hydroxide is an alkali. All the alkalis are bases, but all the bases are not alkalis. You know that. Base sodium hydroxide, and the acid is hydrochloric acid, and it forms salt and water. So here sodium hydroxide, the base, is added to hydrochloric acid. It forms sodium chloride salt and water. Here you see H plus, acid forms H plus ion, bases produce hydroxide ions. When these two cancel each other, it forms water. So remaining we have sodium and chloride, that forms as sodium chloride. This question may be asked in a different way. You may be asked to write ionic equation for neutralization reaction. This reaction with base and acid is also known as neutralization reactions. So what is neutralizing? Base is neutralizing the acidic character. So what is the ionic equation for neutralization? H plus aqueous, OH minus aqueous gives H2O liquid. So this is the equation for neutralization reaction. Good. And we are at the end. Let us discuss the final property, reaction with metal oxides. You know, metal can form two kinds of oxides: basic oxides, amphoteric oxides. Only aluminum, zinc, lead will form amphoteric oxide. That we will discuss. Regarding these types of oxides, we will discuss in some other video. So we are taking a metal oxide and it is added to acid. It forms salt and water. Metal oxide, let us take copper oxide with hydrochloric acid. It forms, what salt will form? You see, we have copper metal and here chlorine in hydrochloric acid. So it is copper chloride, CuCl2 plus water formula we will know, H2O. Now we have to balance the equation. See, we have one copper, right? One hydrogen but two hydrogen, two chlorine, one chlorine. So it is very simple. Add 2 here. So now the equation is balanced. Okay. So this copper chloride is somewhat blue-green in color. Okay. Good. So these are the 4 chemical properties of acids. So just I will repeat. Acid is common when it is added to metal and metal carbonate and with base and with metal oxide. This is what we have seen. Okay. When acid added to all these things, we got common product, salt. Common product is salt. So in with the metal we got hydrogen gas. With metal carbonate we collected carbon dioxide gas. Okay. Here we get water and here also water. Okay. So this is what the chemical properties of acids. And I told you one thing. I will explain how to test the presence of hydrogen and carbon dioxide. Test for gases, hydrogen. Okay. See, we have a jar full of hydrogen gas. So when you bring a burning splint, near to this and open this lid, when hydrogen gas comes, it will put off the flame with a sound. Top. How a cracker gives sound, this hydrogen will put off this flame with a sound. So easily we can say hydrogen gas pops the lighted splints. Next, test for carbon dioxide gas. Okay. This carbon dioxide, we need to take lime water. Okay. In a jar or in a beaker, you take lime water. You know, while breathing out, we release more carbon dioxide than oxygen. So this experiment you can do at home. Take a small piece of lime, dissolve in water, have a straw and blow air, just bubble it, blow air into that. So the carbon dioxide from your mouth, when it goes into this lime water, you will notice the lime water will turn into cloudy or milky. Why? It is due to the formation of calcium carbonate. Yes, this is what is going to happen. Okay, let us say we have carbon dioxide gas in this, and if you make arrangement to pass into this carbon dioxide, here carbon dioxide will react and it turns milky or cloudy. Why? The lime water changes into milk color, milky white. What we are taking? Lime water. What is lime water? Lime water is calcium hydroxide, slaked lime. When carbon dioxide passed into this, it will form calcium carbonate, which is a precipitate, a solid, insoluble solid, and it gives water. Okay. Very simple reaction. We studied the third property. Base plus acid gives salt and water. You see, carbon dioxide is an acidic gas which is soluble in water. So this calcium hydroxide, already it contains water. When this carbon dioxide and passed to this, initially this carbon dioxide dissolving into that and it may form as carbonic acid. See, acid plus base gives salt and water. This calcium carbonate is a precipitate insoluble solid which is white in color. Because of that only the lime water changes into milky. I hope you understood the chemical properties of acids along with test for hydrogen gas and carbon dioxide gas. And thank you for watching this video.